everybody. Welcome to another episode of the Painfully Fabulous podcast.
Today, we have two special guests, and we'll discuss the research of rTMS and CRPS that is happening at McMaster University.
Thank you, Stevie and Dr. Nelson, for joining us today. Perhaps we could start this off by asking one of you to explain to our audience what rTMS is.
For sure. Yeah, so rTMS is a non-invasive form of brain stimulation. So it stands for repetitive transcranial magnetic stimulation. And what we do is we deliver a series of magnetic pulses above the scalp, and those pulses penetrate into the scalp and activate the upper layer of the brain. And what we can do is by delivering these pulses in a repetitive fashion, typically it can be as high as 10 hertz, if not higher, but in our research, we deliver them about 10 pulses per second, is we can actually modulate how the brain is functioning in certain areas. And that's what we call neuroplasticity. And so in specific application in pain research, what we're trying to do is target areas in the brain that are responsible for the perception of pain and modulate the function of those areas in a way that we could potentially block pain signals. So the way we do that is we apply this coil. It's about the size, maybe about 6 inches in length, and we apply it over the area of the brain that's known as the motor cortex. So that is the area that's responsible for moving and controlling the limbs of our body. So in our study, if an individual has CRPS of the upper limb, we would target the area of the brain that is responsible for controlling the upper limb. And what we do is we place the coil over that area. We use a software called brain neuronavigation that allows us to understand where we are relative to the brain. And we apply a series of pulses, typically about 2,000 pulses to that area, and it takes about 11 and a half minutes. What those pulses do is they're non-painful, again, non-invasive. To the participant, it feels like someone is tapping on your head, and it sounds like a bit of a click, but typically participants will wear earplugs, they'll meditate, kind of get into a Zen state while we do the stimulation. So it's a comfortable experience. But what's actually happening underneath the scalp is we're activating areas in the brain that are actually deeper in the brain, responsible for pain perception. So if you imagine it as the motor cortex, the area we're physically stimulating, as almost a window into deeper parts of the brain that are responsible for modulating pain signals. So all the pain signals from the body come up through the spinal cord into the brain through what's known as the thalamus. And so that's really the gate into the pain areas of the brain that are responsible for perception. And so the thought is, if we can block that area, so put a roadblock in a sense, then the pain signals can't arrive to the front part of the brain where pain perception really occurs. So the goal is to basically set a roadblock before those pain signals can even arrive to the front part of the brain. So that's the main theory of rTMS. There's some secondary applications with it as well in pain, and some actual really recent literature that has shown that we're actually activating areas in the brain that are responsible for endogenous opioids. So that's our own natural body's painkillers. And what we see is with the rTMS stimulation is those painkillers are being released. So it's giving an analgesic type sensation because of that release. So that's the second form of pain relief in that sense. And then the third is these areas, some of them are deep in the brain. What we see is they're very hyperexcitable. And what that means is they're very excitable to signals that aren't typically pain signals. So in an individual with chronic pain, the limb or the area that feels pain isn't in danger in any way. And the body's natural mechanism for pain is, to alert to danger so we get out of a dangerous situation. But with chronic pain, these signals are being interpreted as a pain dangers response, even though there is no real danger or injury happening to that area. And so what we're trying to do is suppress that excitability so the brain isn't viewing these signals as bad pains type signals, survival type signals. So we're trying to suppress that type of response. So it's interpreting signals in a way that isn't in pain. So I know it's a lot, but in summary, the three main things are blocking the pain signals from the thalamus area, releasing endogenous opioids, and then the third is suppressing the hyperactivity in the pain processing areas of our brain. So that's what we believe rTMS is doing. And again, we don't have a full understanding yet within that. That's kind of where the literature tells us what's happening and what we suspect is occurring, but there's still a lot of work, even investigating mechanisms of rTMS, not only for pain, but its use in other applications as well.
I would just add to that, in and around the idea of the 10 hertz stimulation that Stevie mentioned. So that's delivery of the stimuli for 10 pulses per second. So there are many different protocols you could apply to the brain. Some of these are very low frequency, some of them are high frequency, some of them are patterned. And this stimulation falls into the category of high frequency. And in the previous literature, in other pain conditions, high frequency stimulation has been shown to have the most beneficial effect.
Mm-hmm.
And so this is why we've chosen to use this in this particular study. I'd also mention another feature of this study is that it is a feasibility study. It's our first encounter with CRPS and using this type of stimulation. And we're trying to see whether or not people improve in their pain perception. It is not a large scale study. It's a small scale study. And it's small scale in the sense that we don't have a placebo controlled group in this work. So everyone who participates is receiving the real Verum rTMS. Future studies from our lab will most certainly do a different type of study, which allows for both a placebo and a real rTMS to be experienced by each participant.
Mm-hmm.
Mm-hmm.
Wow.
Yeah. Can I just ask too, I know you had mentioned that certain areas of the brain you would use, like say for the upper extremity and stuff. Some that suffer from CRPS either have the lower limb or some even a full body. Would this study possibly benefit them, or how would it be done differently?
Yep. So great question. We have individuals with lower limb CRPS in the study. We're targeting the same general area, so that's the motor cortex, but we're targeting the leg representation in that part of the brain. So it's still within the same area, just a little bit of a more specific spot. But to your point about overall pain in areas that might not necessarily be the limb, that's an excellent question. And that's something that's really been pushed right now in the rTMS literature, because there are a lot of pain conditions, fibromyalgia, for example, or neuropathic pain that aren't necessarily restricted to an extremity. And what we're seeing in the literature is, and again, this goes into the fact that we're using the motor cortex more as a window into the brain, is although we're targeting the hand representation, the arm representation, or the leg representation, it's really those downstream effects that are what's causing the pain improvement. And those are irrespective of if it's an upper limb, lower limb, torso, whatever it may be.
Mm-hmm.
So to give an example, we worked with an individual 2 summers ago who had neuropathic pain. And the main pain experience was in the torso area. So it was electrical burning type pain. We targeted the hand representation for that exact reason. It gives us a window into the brain, and that individual experienced a benefit from that. And the literature is showing that in general, where as long as you're targeting motor cortex and you're stimulating in that area, the pain is really irrespective of where the pain is experienced. We can see a benefit. And to the point of brain areas, there's been a lot of debate in the literature about really 2 areas in the brain for this type of stimulation. So motor cortex, which is the one that we use, and it seems to be the push now in the literature. But the other one was what they were trying to do was in dorsolateral prefrontal cortex. So that's an area that's more anterior in the brain, more in the frontal cortex, that's responsible more for pain perception itself. And although they are seeing some benefit in that area, it seems the most robust results and the larger scale results are being shown from motor cortical stimulation.
Mm-hmm.
So that's why we target that area. And it seems to be the trend in the literature. In rTMS in general, the technique, at least in pain research, is relatively new. So rTMS, and Amy can talk to this as well,
Mm-hmm.
as a technique has been around for several decades,
Yeah.
20, 30 years.
Wow.
But it's been more recently that we're seeing that the potential benefit of it for pain. So there's been a lot of trying different protocols of rTMS. So as Amy mentioned, 10 hertz pattern approaches, even something as small as the amount of pulses we give. How long do we give them for?
Mm-hmm.
Does someone come in 5 days a week? Do they come in for 10 days? There's so much variation right now in the literature and different groups trying different approaches. So we're really trying to work towards what could almost be a standardized approach, I think would be beneficial, where these are parameters that seem to work the best. We really have 2 so far. That is motor cortex site for stimulation, The second is the 10 hertz stimulation. So those two seem to be the gold standard, at least in that area. But there's a lot more fine-tuned nuances with rTMS that seem to be every group is trying their own thing. And we're trying to get to a point where I think we can demonstrate this is the best approach globally. So that's one of the big areas of research with rTMS with pain.
And in our study, I just add that we're actually delivering stimulation 5 days a week for 4 weeks. So this is rather intense in terms of the total number of pulses that are being received by participants relative to other research studies. And we chose this because we observed in some of our earliest participants that changes were first observed around the 2-week mark. And so after finding that, we decided that it would be best to continue delivery of TMS to potentially amplify these results. And then further to that, we have a washout period whereby we reduce the frequency of rTMS over the course of the following 6 weeks. So after the 4 weeks of stimulation, they receive rTMS for twice per week for a week. And then they have it once per week and skip a week in between to ultimately wash out to 0. And then we reassess at several frequencies afterwards to see how long the effects can persist.
I was just going to ask, are you able to provide us with like an average of the relief that's been provided from rTMS, or is it still too early to tell, which is understandable?
So in our study, so we have a participant who is 1 month out from finishing the treatment, and they're still experiencing the benefit at that time point. So their next check-in is going to be at the end of this month. So we're going to check in every month on up to 6 months. So that's what we're seeing in this study. In the literature, it really depends on what this study does. So there are studies where they'll deliver 1 session of stimulation and they'll see a benefit. In CRPS specifically, I've seen one where they'll see a benefit up to 90 minutes or a day, for example. There's some studies that will do treatment for 6 weeks and see a longer period of relief. So what we believe is that the effects seem to be cumulative in nature. So the more sessions, and this isn't a matter of, there's a maximum here, there's a kind of an optimal period, but that sessions build upon each other. The neuroplastic changes are being built upon each other. And at least in our current protocol, those changes seem to occur, or at least the effect from those changes seem to occur about 2 weeks.
Or begin to occur.
Begin to occur, yeah, at about 2 weeks. And right now we're seeing it extending up to 1 month post-treatment. Obviously, the goal is to facilitate the relief as long as possible. It might be a matter of having someone come in like we're doing right now with that washout period, and then maybe they come in for a top-up 2 months down the road, then 6 months, then a year. So we can try and prolong that effect as long as possible. That the really long-term effects, we don't really know just yet in the literature. That's something that's still being tried. But the goal in general is to prolong these for as long as possible, but also delivering a treatment that's accessible to an individual. So coming in, for example, for months on end can be really difficult. So what is the most optimal time that we can deliver this that is, doing the best changes neuroplastic wise, but also is accessible for an individual to receive, and that gives the most benefit in terms of the outcome as well. So that's something that we're really trying to work on, not just us, groups in general with rTMS.
I'd also add that we aren't necessarily abolishing pain in these individuals. We are reducing pain. That so far, I think we've been successful in seeing that in all of the individuals we've tested. And if I could quantify that, which I think was part of the question you were asking, like how much improvement do you see? I think it's fair to say it's about 30%, and some people maybe a little more.
Yeah, up to 50 in some.
Up to 50 in some people for this duration.
It's also the quality of the pain itself. So what we've seen in some individuals is their baseline overall pain, say they started at a 9, might come down to a 6 or a 5, but then they'll note that a pain attack, the severity of the attack has been reduced, or the sensation has changed. So maybe a burning sensation has now been reduced. So pain is obviously a very complex phenomenon. There's a lot of aspects to it. So looking at pain in general, we see an improvement, but we even looking deeper into it, there's specific things that we see a change with as well. Quality of life has been something we've been seeing a benefit. Yeah, depression, anxiety, these type of things. So
Are all benefited.
and again, it's especially with those aspects, it's tough to tell if it's related to the pain that those are improving or those are improving by themselves as well. But we are seeing those benefits.
Wow, that's incredible. Personally, I'm amazed. Selena, you look like you have a question. I'm sorry.
I have a couple, but my first one is, you said a lot about the perception of pain, and I'm kind of a mental health guru for the group. So I'm constantly trying to change people's perceptions of their pain and how they view their pain impacting their daily lives. Do you think that if you were to work on your mental health part of it, as well as maybe rTMS along with it, you could see even better results from the rTMS?
Excellent question. And that's actually something we've been working towards in the follow-up study, is having adjunct therapies with rTMS. So having the support for more perceptual changes, cognitive behavioral therapy, even just support groups in general. A lot of the people we see feel very isolated in their pain experience, right? And a lot of people don't, unfortunately, realize that there are a lot of people that go through the same situation. So even just the social aspects of them coming to the treatments, interacting with us, even that I think has its own benefit. So having the overall support, I think, is really impactful and could potentially improve any benefits from the stimulation itself beyond the stimulation.
And at one point, we were also thinking of doing some EEG, because our lab does neurophysiology. We do lots of neuroimaging, and one aspect is EEG, and looking at some of the alpha rhythms and how those are modulated with meditation. And we were thinking at one point to see if individuals can train with the EEG in addition to having the repetitive TMS. So the rTMS we know as a potent modulator of neural activity, and we know it can create plasticity. So future goals for our research would involve adding additional either sensory motor training or cognitive or relaxation state training to enhance the effects of the rTMS.
Absolutely.
Yeah, amazing.
I think just from living with CRPS, we all know that the mind, pain is definitely all in our brains. It's difficult to say to most patients, but it truly is. So this is just amazing. Amazing. Sorry, Christine, you go ahead, love.
I was just going to ask, I think I've had discussions before, but I personally have ketamine infusions. I do the low dose, the high dose. And for our viewers' sake, I'm just wondering, is this something that we can do as a treatment while doing your study as well?
Yep. So we don't require any withdrawal of treatment for the study. What we do ask is that any treatment that's ongoing is maintained. And the reason for that is, say during the study, someone decided to try something new outside of the rTMS, and that gave an improvement, then it'd be tough for us to tell if it's the stimulation or the new treatment. So as long as what's being done has been consistent in their treatment regime, then we can see, does the rTMS have an additional benefit beyond kind of where their baseline is at. So we don't ask for a withdrawal of treatment for that aspect. What we do look for, though, especially in medications, is safety aspects. So we want to ensure that all the medications are not contraindicated for the stimulation. The main contraindication is increasing the risk of a seizure. So we want to be very careful that that risk doesn't present. There's very few medications that have that, and we haven't seen that in the research so far, people on these medications. But we are very careful in our screening to ensure that there is no risk because of the treatment that someone's on while they go into the study. So there's a big screening involved for that.
And I've been doing rTMS for many years, for sure. I don't know, 18, I'm guessing on that, but for sure. And I would say that I've not seen a seizure occur due to rTMS as of yet. So, yeah, and that's because we have such strict screening criteria. And also for this particular study, we deliver the rTMS in 2 locations. One is at the McMaster University within my laboratory, but another is over at a hospital to service the east end of Hamilton. Hamilton is a sprawling city, and at the East End Clinic, it's a pain clinic, and we're able to deliver stimulation at that site as well. So we can bring in participants from St. Catharines and Welland and Niagara Falls and that area of Southern Ontario for participation. So we're really trying to service as many people as we can in this study.
I just really quickly want to ask, I'm sorry, and we might have already touched on it a little bit. Why specifically did you guys want to target CRPS? Out of all the pain conditions out there, why this one?
Yeah, great. Yeah. So basically COVID shut our lab down for about a year and a half. So unfortunately we couldn't do any research during that time. But what we really focused on during that period was really searching the literature to see where our neurophysiological skills could be applied to. So typically these techniques we use have been used to understand mechanisms or understand conditions or how the brain functions. But there's been a real change and realization in science in this field where these techniques can also be used as a therapy or as a intervention. So during COVID, we kind of were working towards some new ideas, and we met with a collaborator who his name's Dr. Harsha Shandana. He's a anesthesiologist here at Hamilton that runs a pain clinic. And he had an individual at the time who had neuropathic pain for 11 years and no treatment had worked for the individual. And he had heard about rTMS being used in Europe and other locations for pain and asked if we could potentially do a study using rTMS for this individual. And so that was our first lens into the rTMS pain research space. And we did that study and we saw a nice benefit for this individual. And speaking with Dr. Shantana, he informed us that there's a lot of individuals he sees in his clinic with CRPS. And unfortunately, a lot of these people aren't responding to any medications that are prescribed or any of the treatments that are currently available. And he said, and looking at the literature as well, we saw the opportunity that maybe rTMS could be a potential benefit for these people. So that's where kind of the study evolved from was Harsha saying, I have these group of individuals that I think this could benefit, and we need to do a study in that space. Also, CRPS is a relatively new pain condition relative to some other ones. And so the literature around CRPS is more limited. And so there's a real need for not only treatment therapies, but also understanding more about CRPS in and of itself. And as neurophysiologists and people that study mechanism and neurobiological underpinnings of conditions, that is exactly something we wanted to use our expertise for. So we've talked a lot about the rTMS part of the study, but another big aspect is understanding more of the neurological mechanisms of CRPS, see if those potentially change because of rTMS, and better understand the underground or the underpinnings of the condition as well. So that's kind of where it all came into play.
Well, thanks for that. I appreciate it.
Yeah, no problem.
We all do.
Truly.
I have another question too. Go ahead, Christine.
No, you go ahead.
Okay. So I myself have CRPS in my right hand, and that limb also I lost function in. So my right hand, I can no longer move my fingers, unrelated to the pain. It was a separate situation that caused it. Has rTMS been used for anything other than pain treatments? Like, it's almost like a stroke victim who can no longer use their hand. Is there, a way this might be used to repair or reconnect those connections in the brain?
Yeah, so I mean, most certainly there are many studies that have investigated the use of rTMS in individuals who have had a stroke, and that's a great example that you provided. And there is some evidence that there's some benefit, but other conditions as well. So currently, it's approved for use in individuals experiencing depression and obsessive compulsive disorder. And it seems as though the literature is moving it into more psychiatric disorders. Movement disorders, there is some evidence that it's been used as a potential treatment, but I have yet to see sort of the long-term success of those. For example, in Parkinson's or other disorders of movement. Yeah.
Wow, I I was sorry, I don't mean to interrupt. I just find it amazing that I've never heard of this before, but yet it's been used for like even for depression and stuff like that. It's interesting that it doesn't get out there when it's, you know, just like CRPS, you know,
Yeah.
you don't hear about it, but it's there.
That's what we're doing today, though. We're getting the word out about our rTMS and
Yeah.
CRPS.
That's something Amy and I've been working on in general is there's
Yeah.
a real need to increase the accessibility of research and science, because what we find is it kind of ends there, right? Like you do a research study, you publish your results, you go to a conference, you present your findings, but you're presenting to other researchers, other scientists, you know, and that's kind of where the buck stops. And there needs to be a better translation of that into the into the people with lived experience, because that's ultimately science is to help people. And if we can't translate that knowledge in an accessible manner that people can use and say, hey, there is an option outside of, you know, medication or different types of traditional treatment, we need to have that options available for people. So yeah, we really try to push that initiative, especially in Hamilton area, but across the whole country, there needs to be a better awareness of what's going on in science and research and what people can take part in. That's not just traditional medicine that a physician would prescribe, like a medication, for example.
Right. And that brings me to my next question. So there has been word about research similar to yours being done in the US, and I believe it's Syracuse University. And I'm just wondering if you've heard of that and what you might have any information about that.
So I'm aware of, there's one in Syracuse. I think there's one in Stanford potentially as well. There's a few sites, at least in CRPS. There's more sites doing pain in general with rTMS. And it's a very positive thing, because in research, the more a finding can be replicated by independent groups, the more credential, the more validity there is to the findings. So it's great if one lab group shows a benefit, but if multiple groups, not only in the US, but globally, are showing a benefit, then it really not only helps in the sense of the science perspective, but it can also help in the sense of driving legislature to show this is a therapy that we're seeing benefits, that isn't causing adverse effects, that should be something that a physician could prescribe to an individual. So it's benefiting science, but also the political aspect of it as well. So the more people, the better, and the more opportunity to find new mechanisms, new things that can be targeted, ways to optimize our approaches, the better, because ultimately it's all to help more people. So it's great that this work is being done. I was recently at a conference, Canadian Pain Society, and it was amazing to see across Canada the national effort in pain, not only in CRPS, but in pain management in general. It's great to see how much work, science, and thought is going into treatment beyond traditional medications and different experimental things, meditation, mindfulness, all the way to brain stimulation. So it's really inspiring to see that work being done at the national level as well.
Absolutely.
Yeah, I'm just wondering, I know it takes time for studies and to go to legislature and everything. I'm hopeful, and I'm sure everybody else is, that something like this is going to be government funded, if you will. I find, you know, I've done brain training and stuff like that, but it gets to the point where I can't afford it anymore.
Yeah.
So, you know, that's something I think as a group, we're all hopeful that something like this could be available to us. Yeah.
That's exactly where Stevie and I would like to see this go. We want to make something that's accessible to people. And I just echo Stevie's words. I mean, my research in the lab has really been focused on neural mechanisms, basic neural mechanisms, and we rarely touched any special population that had a real need for that information. Only in the last couple of years have we made that transition to actually make the end user the target of the research, the goal of the research. And so as the research evolves in the lab, we're taking the ideas and opinions of the end users, the individuals with CRPS, and they're helping to guide our research. They're helping to create change. And we hope to see that this cycle continues. You know, for example, one of our participants also presents with fibromyalgia. And we didn't we really didn't have the knowledge that these two things could present at the same time, or how they would become comorbidities. And that's really guided our lab to now develop new research studies specific to fibromyalgia. Not Stevie's work per se, but another graduate student's area of research is now focused on that, and how neuromodulation, with or without other therapies, may assist with pain in these. So we really want to get the message and the materials and the treatment to people. And so we're working really hard right now to demonstrate benefits if they exist. I think at this point we're optimistic because we are seeing benefits in the data, I would say. And I'll say that as a scientist, I started this research with almost a negative perspective, because I rarely have my hypotheses come out correct. I'm almost wrong more than I'm right. And so, it was really exciting to see the data coming in and showing that there are benefits. And so I'm in fully, and more and more of our research team in my lab seem to be jumping on board and wanting to participate in this important mission.
Wow. And now that you've led me to that, my next question is, how can our viewers get more information on how they could be possibly part of the study?
They can go to our website, www.conquercrps.com. Go ahead.
That too.
Yep, that's a great avenue. Reaching out to me, my contact information is there as well. I meet with every person who's interested in the study. I set up a phone call with them to discuss the study further if they'd like to participate, and then we set up subsequent calls to discuss screening and things like that. But I'm more than happy to discuss the study with anyone who's interested, any logistics regarding the study or specifics regarding it. So, yeah.
So is someone located in Windsor too far to be part of your study?
So we're looking at right now having the option for accommodation on site on campus. But like Amy said, this is right now we have a small funded study. The goal is to use this data to apply for a larger funding opportunity where we could potentially support that even further with more people. Ultimately, accessibility is our main goal here. And so someone from Windsor could stay here, for example, and participate in the study. So that's something we would like to do. Unfortunately, at this point, we don't have the funds yet to be able to support that. Your organization is going to help tremendously with being able to help, even with just transportation and gas costs, because as we all know, the price of gas right now is very high. So yeah, we have people driving from Toronto every day, or Milton. So we want to be able to support those individuals, people that are taking the bus, supporting their bus fare. So, or even providing a taxi service or a shuttle type service. So,
or in very special instances where individuals need accommodation, we're trying to find ways to have affordable accommodation on campus. But I'm finding that it's still quite expensive. I'm just working on that this afternoon, trying to get those numbers down a little bit. But we're doing what we can. So we're trying to make it accessible, even at this pilot stage.
I just want to add my 2 cents. I don't know if either of you guys are aware, but in my younger years of CRPS, I was unable to get to local treatment, and I had to go online and create a fundraiser, a GoFundMe. And I asked my family and friends to help me get there because I had to travel 4.5 hours away. And I also had to have accommodations while I was there. And so this year on August 19th, for the 5th annual Walk to Conquer CRPS, we are asking everybody to please raise funds for this research, because every penny raised is going to go to patients who are unable to afford the transportation costs to go to all of these appointments, and every penny counts. So fundraise, everybody.
Absolutely.
I'm just going to comment on that. That's a really important point, because the research itself is not costly. We have McMaster owns the equipment through all of the different research grants that I've obtained over the years. Stevie is a graduate student in biomedical engineering. His salary is paid for. There's no personnel costs associated with this. The only cost to us is getting the individual here on campus. And that's it. So that's where we want the money to go.
And that's how we make history happen. rTMS is proving successful in so many different areas. And if we could just get people to McMaster University,
Mm.
we could further this.
In reality, we are raising for ourselves to help ourselves get there, right? So I really appreciate the work you guys are doing. You know, honestly, it's the first time I've felt heard, to be honest. So thank you for everything you're doing.
No, thank you.
Yeah.
We really appreciate your organization's support and having us on to discuss this and being willing to participate in our research. You know, we're very lucky to have a group of individuals that have been participating in our work and been helping us, like Amy mentioned as well. So it's been a terrific opportunity meeting these people, working with them. Yeah, it's been an excellent. Yeah,
Great experience for Stevie and I. A lot of the stories and information that's relayed to us can be very heartbreaking. So it can be difficult for experimenters because remember, we're scientists, so we're not necessarily trained as clinicians. So we may not be able to sort of understand or know how to compartmentalize that information. So sometimes we take on a lot of that emotional burden of the patient because we're hearing these stories. But as scientists, we want to achieve the best for these individuals. And so we're learning too. We're learning how to work with individuals with CRPS, hear their stories, understand their pain, but not necessarily absorb all of that on our own, because that's really taxing. And we've learned that that's the situation that we experience.
You'll hear a lot of sadness, I'm sure of that.
Yeah,
but
we do. Yeah. And I think clinicians are trained to be able to handle that information and know how to put that in a place so that they can be objective. So in our case, we hear these things, but we're not trained in that way. So, but we are really enthusiastic. And so we hope to create a great change in our society with this work.
it seems you genuinely care, and that alone is something that that a lot of patients just need. You seem to truly care, and I'm so excited to see what happens with your research moving forward. Truly.
Thank you.
I didn't mention with the CRPS stuff. So my father suffers from chronic pain as well. So he has neuropathic pain since I was 3 and was disabled for it. So there's a very personal component to it as well for me that really drives my work in this area. Is, you know, I've seen my dad suffer with it. He's someone who doesn't respond to medications. So, you know, I've seen the need for it at a personal level as well. So that's really what drives my initiative in this work as well, is that. So
thank you for sharing that, Stevie. That's incredible. Well, may this prove successful then.
Yes, yeah, exactly. we're hopeful. Exactly.
Oh. Well, thank you so much for taking your time with us today and sharing so much. I mean, you've really, I mean, I'm going to go look up more stuff because I'm so excited about this.
Let us know what you think about rTMS in the comments below, and if you've registered for the 5th annual Walk to Conquer CRPS in August. Subscribe to get notified for our weekly episodes and highlight clips.